All right, welcome here to lesson number 3 in using trig ratios to solve for a missing angle. If you've gone through the other two lessons, I went through how to use sine, cos, and tangent in order to find the missing side given an angle as well as one of the side lengths. And so we've gone through some of the general ones. This lesson here is going to go through in some word problems in how to solve for angles, or sorry, sides and potentially some angles in that. So we're going to do a couple. Some are going to be a little more difficult. Some might be a little easier, and that's good. What I'd like you to do is I'd like you to pause the video each time when the question is ready. Try to solve it on your own. I'm going to take a little pause there as well in the video, and then come back and try to figure out did you get the answer correct, okay? Because we want to kind of practice and see how we're doing, and it's nice to get some affirmation that something is in fact correct. So the first one here says that Jasmine is climbing a hill which has an angle of elevation of 4 degrees. After 3 hours of walking, Jasmine has walked 8.4 kilometers. How many meters above her starting point is Jasmine after 3 hours? Draw a diagram, try to solve, pause the video now, come back when you're ready. All right, here we go. Can we solve? Well, the first thing we need to do is draw a diagram. So I'm going to start with this hill, which is 8.4 kilometers long, or at least that's how far she has walked. And we know that it has an angle of elevation of 4 degrees, which means that we have this line underneath and we can put a 4 degrees in there. Finally, it's asked for how many meters above her starting point is Jasmine. So it's asking for what is that vertical displacement from the bottom to where she is now. And so we want to try to find that. This is a right angle triangle. I just didn't draw it in, that little right angle. Apologies. So let's solve. First of all, we want to label our sides, hypotenuse, adjacent, opposite. We are given the hypotenuse. We want to find the opposite side. So given that information, there we go. We're going to use sine law, or not sine law, sine ratio. Sine law is something different. Plugged in, we're going to multiply across, divide by 1, and we should get an opposite side of about 0.585 kilometers. Now, did you catch the last little bit? It's asking how many meters. Well, there are 1,000 meters in a kilometer, so we multiply that by 1,000 and get 585.95 meters above her starting point. There we go. I'm sure you did okay, right? Yeah, hopefully. All right, perfect. Okay, let's try this one. Sammy is standing 40 meters from the water tower and measures the angle of elevation to be 50 degrees. What is the height of the water tower? All right, pause the video, draw a diagram, come back when you have your answer. All right, here's the water tower, and I'm going to use our water tower here in Steinbach. And to solve, Sammy is standing 40 meters from the water tower. So there's that horizontal distance of 40 meters. He is looking up, or she is looking up, I'm not sure. There's no name given, or no gender there. Okay, at an angle of 50 degrees, definitely not drawn to scale, to the top of the water tower. What is the height of the water tower? Well, let's start by, there we go. Let's start by labeling. We are trying to find the opposite, we're trying to find the opposite side given the adjacent side, and we have our angle of 50 degrees. So because of that information, we are going to use tangent, which means that we're going to plug everything in. The adjacent side is on the bottom, multiply, divide by 1, and we should get a height of 47.67 meters. Did you get that? Hope so. Yeah. All right. So the water tower has a height of 47.67 meters. Okay. So far, so good. All right. Let's try this one. This one has a challenge to it. It is a bit challenging. Give it a shot. Try to figure out the perimeter of this table with only given that diagonal of 30 centimeters. Can you do it? Go for it. Give it a shot. Try it out. Once you have kind of gotten to a point where you might need some help, start the video back up and we'll go through the answer. Okay, tough question here. Now, I've seen a bunch of different ways of trying to solve this, and some may work, some may not work. But what I'm going to say is let's make this into a bunch of little right-angled triangles. Now, you'll notice there that they're all right-angled. There we go. Okay, so I'm going to look at that bottom one there. It's a right-angled triangle where the hypotenuse is 15 centimeters long. Okay, so far so good. All right, now we want to try to figure out what is that angle right there, because we need an angle, and that's the one we can actually solve for. The entire circle, if you want to think of it that way, all the way around, is 360 degrees. This is an octagon, which means that there are 8 sides, or in my case, I have 16 triangles inside that octagon. Okay, each of them has the exact same angle. They're all identical triangles, which means that if I take 360 and divide it by 16, I'm going to get an answer of 22.5 degrees. All right, so that's going to give me that angle, and now I can get rid of all those others, and I'm going to focus just on that one small triangle there on the bottom. So I'm thinking 15 centimeter hypotenuse, angle of 22.5 degrees, which I didn't label in there, but that's okay. And so I'm going to use sine in order to find the opposite side. I'm trying to find part of the perimeter, that bottom piece right there. When we do that, we're going to get a length of 5.74 centimeters. Now that is one little portion, that's half of one side. Okay, and because of that, we can multiply by 2 to get one side, multiply by 8 to get all 8 sides, or just multiply it by 16, and we should get a perimeter of 91.84 centimeters. That's a tricky one. Okay, that's about as hard as they're going to get in this case, but I think it's a little bit fun to look at different things that we can problem solve in order to try to find the answer. Thank you for watching this. Time to work on your assignment. Have a wonderful rest of the day.